Hi folks, welcome back to Math with Captain Rod. This one definitely felt like it needed some theme music to start it off. We're going to talk about exponential functions, and I think they're kind of wild types of functions, so I decided to start that with the appropriate theme. Alright, so exponential functions. Here's a couple examples of exponential functions. Y equals 2 to the x and y equals 1/2 to the x. We're going to look at these kind of graphically, and we're going to just talk basic properties of exponential functions in this video. We're going to start with this guy. So that's an example of an exponential function, and what I'm going to do is graph it. And to do that here, I'm going to draw myself a pretty good coordinate system, if you don't mind. A reasonable coordinate system here. Now it's not perfect, it doesn't need to be perfect, but I'm just going to say, we're going to do like 1, 2, 3, 4, and I guess we'll go 1, 2, 3, 4, 5, 6, 7, 8, but I'm not going to label them. Now, graphing. I like to just do tables when I graph quite a bit. X, Y. I think this is a art that's getting kind of lost, and we're going to do quite a bit of this in my class before the end of it, before it's over. And the idea is just pick values for X, calculate values for Y. I'm going to start with a simple one here. So we're going to start out with X equals 0. So when we calculate Y, it's going to read 2 to the 0, and 2 to the 0 is equal to 1. If you're not familiar with this, I'm going to put that in another video. For now, I just ask that you take my word for it, that anything to the 0 power is equal to 1, as long as it's not 0 to 0. But 1 to the 0 is 1, 5 to the 0 is 1, 100 to the 0 is 1, and I'll save that reason for another video. If x is 2, then y is equal to 2 to the first power, which is 2. And if x is 3, whoops, I'm sorry. What I meant to say was if x is 1, then y is equal to 2 to the first power, which is 2. There we go. If x is 3, then y is equal to 2 to the third power, which is 8. 2 times 2 times 2. And if x is 4, then y is equal to 2 to the fourth power, which is 16, and so forth. Now, I've got all these positive values. I'm going to go ahead and get a couple negative ones as well. So if x is minus 1, y is going to read 2 to the minus 1, which is 1 over 2, right, which is 1/2. I'll just do 1 or 2 more. If x is negative 2, y is going to be x to the minus 2, which is, remember, the minus sign means put it downstairs basically, 1 over 2 squared. Yeah, I meant that to be 2, not an x, but which is 1/4. Do one more, minus 3. Then y is going to be 2 to the minus 3, which is 1 over 2 cubed, which is 1 over 8. Now you'll notice the pattern here. Well, for starters, you'll notice these are all positive, right? You'll notice that when x is getting bigger, y is getting bigger, and when x goes to the left, right, and y is getting smaller and smaller and smaller. I'm going to go ahead and just plot some of these points. So 0, 1, 1, 2, get them about where they go. 3, 8, I think 8's up here. I can't get that other one. 4, 16 is, I don't know. I guess I can put that there. Right, negative 1, 1/2, so 1 to the left, 1/2 up is not quite, it's halfway between 0 and 1. Negative 2, 1/4. Now 1/4 is just above, the axis, barely at all. Negative 3, just barely above the axis, and there's enough here to sketch my graph, looking something like this. Okay. So there's a graph of y equals 2 to the x. Some important things to point out about it. Well, one, the y values here are always positive. Let's talk domain, because we talked a little bit lately about domains and ranges. So domain is any values that you can put in. Those are the x values. Now, I can put in any value for x. I'm going to get a value out for y. So the domain of this thing is all real numbers. This kind of double R symbol is a quick symbol for all reals. So you can put anything you want in, you're going to get a value out for y. The range of this guy, you'll notice there's no negative numbers. So our range, and I'm going to write this in interval notation, is from 0 to infinity. So let's write it like this. 0 less than y. Let's see here. Hold on. Let me write it like this here. This is what I meant to say. Is y is greater than 0. You notice there's no negative values here. Right? And this is how you graph exponential functions. And again, the idea here too is that when x gets bigger, y is getting bigger in a hurry, really faster. Linear functions, like a linear function would look like this. So, x changes a little bit, y changes a little, x changes a little, y changes a little, and so forth. In a linear function, your change in x and your change in y's are staying constant, but in exponential functions, they're not. And in other types of functions, they're not as well. All right, let's talk about this y equals 1/2 to the x. Put that over there. Graph this guy. This drawing tool I have is really cool for this type of stuff. Okay, y, x, I'm going to do the same thing here. Like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just needs, it doesn't need to be perfect, just decent. X, y, start with x equals 0, y would be 1. Anything to the 0 is 1, as long as the anything isn't 0. In case you're wondering, what is 0 to the 0 power? That's called indeterminate. That doesn't have any mathematical meaning. It's an indeterminate expression. You can't calculate it. If x is 1, then y is 1/2 to the first, which is 1/2. If x is 2, then y is 1/2 squared, which is 1/4. If x is 3, we're going to get 1/2 cubed, which is 1/8. Now, I'm just going to do one or two negative ones. If x is -1, then y is going to be 1/2 to the -1, which is 2. And if x is -2, 1/2 to the -2 is 4, because it's 1/1/2. And you'll notice now that this thing's kind of getting bigger in the other direction. As I plot these, and I'll just start here and move down. So 0, 1, 1, 1/2, 3, 1/8, or I'm sorry, 2 1/4, barely above the axis here. 3 1/8, again, barely above the axis. So you'll notice that it basically does this, and it rides along that axis very carefully, or closely. Now going the other way, -1, 2, -2, 4. So you see that it's getting big in the other direction, kind of in a hurry. Right, so here's a pair of exponential functions. This one going fairly quick. The domain of this guy is all real numbers. The range is, again, y greater than 0. I should have mentioned this before, but it's strictly greater than. There's no equality here because there's no value for x that's going to give you identically 0 here on the left. Right? So again, these are examples of exponential functions. Just pay attention to the standard shape. You notice they both go through 0, 1. In general, any equation that looks like y equals a to the x, as long as a is bigger than 1, it'll have this general shape. It'll look, something like this, and it'll go through the point 0, 1. If a is some sort of fraction, like if a is between 0 and 1, like so, then the function will go through 0, 1 and have this type of general shape. And again, you fill in the details by filling out the points. So what differs is they just get bigger faster, so to speak. So I'm not going to plot all the points, but like if I were to look at y equals 3 to the x, I'm going to graph this in green. I'm just going to do a really quick sketch. It gets bigger faster. It'll look like this. Right? Or something like maybe y equals 1.5 to the x won't get big quite as fast, maybe something like this. Right? That's how they kind of change with different values of a. So this was just meant to be an introductory video into the idea of exponential functions. Right? I hope that this helps. Have a great day.